Hello everybody, welcome to Anantha Lakshmi Academy. Today we are going to discuss one more new chapter of 10th class mathematics, which is progressions. Today's chapter is progressions. From today onwards we will be discussing in further videos as well. So look at the word progressions. What do you recall when you hear a word progressions? As soon as I look at this or listen to this word, I recall something called progress report. In my childhood, when I was studying in school, generally nowadays people are conducting the exams like SA1, FA1. Rather than that, they used to conduct us like unit test 1, 2, 3, 4, quarterly exams, half yearly exams, and finally the annual examinations they used to conduct. Once after everything gets done for the exams, like exam papers got corrected and marks are allotted, they used to send us a report card in which they used to list down the marks for each subject with class teacher and principal signature. They used to send that progress card for father's or mother's signature, basically parent signature. Progress card they used to call it. What do you understand from this example? Progress card is nothing but the way how the student or a child or a kid is progressing in his studies. Progressing is improving, or what you can call how is the performance is going to be. That is a general example of progress. That is not even an example. Just by looking at this term, I recall that particular keyword, which is progress card. That's my own experience. Forget about that for a second, and even before understanding what progression is in mathematics, that is a general example of a school child going to school and writing exams and etc. Right now we are going to understand what a progression in terms of mathematics is. Okay, even before I tell you the definition of progression, let me give you the concept of progression. What is known as a progression? When do you call something as a progression? Okay, so let me give you few examples, like consider the list of numbers like 1, 2, 3, 4, and so on. As soon as I write this list of numbers, immediately people start saying natural numbers. This is a set of natural numbers. Yes, this is a set of natural numbers as well. Let me write down even more examples. Okay, the next one will be like -3, -1, 1, 3, and so on. And the next one would be 2, 2 square, 2 cube, 2 power 4, and so on. And the last one would be 3 comma 3 comma 3 comma 3. Okay, now if you look at the first examples, let me name these list of numbers as well: 1, 2, 3, and 4. All right, now look at this. In the first list of numbers 1, 2, 3, 4, wherein we consider that as a set of natural numbers, if you look at each term is nothing but the number in a list. Each number in a list is known as a term. Okay, so each term is obtained one after 2. How did we get 2? 2 is nothing but 1 plus 1. Now if I do 2 plus 1, I get 3. 3 plus 1, I get 4. Okay, I'm trying to understand or make you guys understand how is this list formed. All right, now if you look at this, each term of this series is obtained by adding 1 to previous number, isn't it? All right, now look at this second example: -3, -1, 1, and 3, and so on. It is going on. So what do you understand from this series? If I do an addition of 2 to each number of this series, if I add 2 to -3, -3 plus 2 is -1, -1 plus 2 is 1, 1 plus 2 is 3. So how did we obtain this series? By adding 2 to previous number, isn't it? Okay, now look at this. 2, 2 square, 2 cube, 2 power 4. How is each term of this series is obtained? By multiplying the previous number with 2. Isn't it? So let me write the same. This is obtained by multiplying 2 to previous number. Alright. Now, this is 3, 3, 3, 3. Each term in this list is nothing but 3. So, we are not going to do anything here. Each term in this particular list is same. Whether you can think that it is added by, it has come by multiplying with 1 or anything else. It is just the same number which is repeated n number of times, not n number of times, because this is an infinite series. It is the same number which is going to get repeated till how much ever this list goes on. Alright, so let us exclude this particular series wherein this is the same number repeating forever. Okay, now look at this 1, 2, 3, 4 and so on, it is going on. So this particular list is progressing. Progressing meaning this generally performance wise, as in the progress card. Say for suppose in the unit test 1 I got 25 marks, 15 out of 25 marks in particular subject, and in the unit test 2 I got 20 out of 25 marks. What is this called? This is nothing but improving. That is nothing but progress. This particular child or this particular kid is making some progress in his studies. Likewise, this particular number is progressing by adding 1 to previous number, and this 2, 3 and so on. Each number, this particular series is progressing. How is it progressing? By adding 1 to the previous number. Understand the term progress? Okay, now you are able to understand this particular term called progress? Yes, progress is nothing but the way you show improvement, not only in general scenarios but also in mathematics. These numbers are improving by adding 1 to the previous number, and this is also by adding 2 to previous number, and this is by multiplying 2 to previous number. Also, we can take examples wherein we divide a particular number by any number. Say for suppose I have 81, 27, 9, 3 and so on. So this is nothing but this particular series is obtained by dividing each term by 3. Okay, isn't it? So this is how it goes on. 81. These are nothing but list of numbers which are progressing. This is when you call a series as progressing. So now that we understood what progress is in terms of numbers, when do you call a list or a set of numbers as progression? When you see some progress. So now you understand the basic definition of progression. When the numbers are progressive, the list is known as a progression. The list is nothing but the series. Okay, as we write on the series, the list, whatever, however comfortable you are calling either the list or the series, that is known as a progression. So in this chapter, in this particular chapter, we are going to deal with two progressions. Now that you understand the term progression, we are going to deal with two progressions, which is arithmetic progression number 1 and the second one is geometric progression. All right. So today, as part of the first concept, I am going to cover arithmetic progression. We have different kinds of progressions. Not only arithmetic and geometric, we also have harmonic progression, which is not there in your syllabus. But when I was studying my 10th class, it was there. Harmonic progression, HP. Okay. So arithmetic progression, in short, called known as AP, A dot P. Geometric progression, in short, known as GP. Alright, today we are going to discuss what is an arithmetic progression, what is the general form of arithmetic progression, what are the parameters of geometric progression in this particular video. All right, so let's get started with arithmetic progression. Okay, arithmetic progression. So in the examples, in order to make you understand what a progression is, the first two examples in which we were able to get the term in the series or the list by adding a particular number to the previous number. Here if you observe, 1, when I added it with 1, I got 2. 2, when I added it with 1, I got 3. So the number that I am adding to each number is the same. That is nothing but when you obtain each number in the list by adding a particular or a fixed number to the previous number, then that is called as arithmetic progression. These two are nothing but the examples of arithmetic progression. So definition I am repeating again. So generally how I explain is, I try to give you the examples first, where exactly this is used, how exactly this is used, and from there I'll try to draw out the definition from yourself, like from the examples, however we can draw it in our own words. I put it in my own words while giving you the definition as well. So if you like this definition, you can follow this as well, or if you are particular about the wordings that are used in your textbook, you can follow that. All right, so we are going to deal with the definition of arithmetic progression. So what is an arithmetic progression? This is nothing but the list of numbers obtained by adding a fixed number to the previous number is known as what? Arithmetic progression. In short, I wrote it. You can write it in the full form. Okay. When do you call a series as an arithmetic progression? If you get the next number of the series by adding the fixed number to the previous number, then we call it as a arithmetic progression. The best example is 1, 2, 3, 4, 5. And so on, the natural number set. How are we able to obtain this? What is the common number that we are using? See here, and previous number here, except the first term. Except the first term, because for the first term you don't have anything earlier to that. For 1 you don't have anything, right? So except the first term. Coming to the second term, see, I am writing it as 1 plus 1. 3, I am writing it as 2 plus 1. 4, I am writing it as 3 plus 1. And 5, I am writing it as 4 plus 1. Isn't it? So each number of the series is obtained by adding 1 to the previous number. By adding the fixed number, which is nothing but 1 to the earlier number. That is known as arithmetic progression. And this fixed number, whatever we are discussing so far, this fixed number, what is that fixed number known as? The fixed number is nothing but common difference, which is denoted by D, small d. What is this fixed number? Common difference. Okay, now let us understand the general form of arithmetic progression. General form of arithmetic progression is AP. Okay, now what did I say? The first term is, we need to exclude the first term because we don't have anything before the first term, isn't it? Now, so let us assume the first term to be A. The first term to be A, small a. And what did we say? The fixed number, the common difference, right? And the common difference is D. From the definition which we have learned, the first term is this. The second term is this plus fixed number, which is nothing but D. A plus D. Now, the third term is nothing but A plus D plus the fixed number, which is nothing but A plus 2D. And again, this goes on. A plus 2D plus D. And so on, this goes on, right? So, if you write A plus D, A plus 2D, A plus 3D, and so on, it goes on. This is nothing but the general form of AP. So the first term is A. Second term, how do you get the second term? By adding it with the fixed number, which is D. Third term, how are you able to get it? A plus D plus D, which is nothing but A plus 2D. A plus D is the second term for which we are adding the common difference. And again, fourth term, A plus 2D plus D, which is nothing but 3D. Okay, this is nothing but, this is how we define AP. And the general form is nothing but A plus D, A plus 2D, A plus 3D, and it goes on. The first term is A. Just because we have A plus D, do not assume this as the first term. No, the first term is always A without common difference. And the next term comes when this is A plus D, A plus 2D, and A plus 3D. Now, because this is first term, we are calling it as first term. Why are we calling this as a common difference? Why are we calling it as a common difference? The question should come to you, or you should eventually able to draw your answer from the series. Okay, let me tell you how. If you take the difference of the first two numbers, like this is A1, A2, A3, A4, right? Now, A2 minus A1. A2 minus A1 is nothing but A plus D minus A. A gets cancelled and this becomes D. Likewise, A3 minus A2 if you do. A plus 2D minus of A plus D, wherein A gets cancelled, 2D minus D is again D. Likewise, even if you do A4 minus A3, you will get D. A5 minus A4 also you will get D. The difference between the consecutive terms of an AP is always D. And provided you have to consider the difference as A2 minus A1, not A1 minus A2. Say for suppose you have a series wherein I'll be writing 5, 4, 3, 2, 1. This is a list I have given you, series or list. Now here the first term is 5, the second term is 4, isn't it? Now each number is obtained by subtracting 1, not adding, by subtracting 1. So do you consider this as AP? No, we are subtracting 1, we are not adding anything over there. So this cannot be arithmetic progression. Most of the students will be thinking like this. No, even if you are subtracting, say for suppose, if I add minus 1 to this set, what happens? 5 minus 1 eventually becomes 4, isn't it? Even if I try to add this, it is ending up as 4. So this is like if you are adding minus 1 to this, you are gonna get the same result. So do not assume anything like if you are getting the next consecutive number by subtracting any number, do not think that this is not an AP. That falls as an AP, because even if you add a negative term, eventually you will do the subtraction. Alright, and one more thing we need to consider is A1 minus A2 you should never do. 4 minus, and now if you do 5 minus 4, it becomes 1. But when you do 3 minus 4, it becomes minus 1. There your ratio, the common difference goes off. Even though the first term is bigger than the second term, we should always calculate the common difference as A2 minus A1 itself. For that, say for suppose, I have a series of A plus D and so on till AK. Okay, kth term. The common difference would be AK and AK plus 1. Till AK plus 1. AK plus 1 term minus AK. It is actually in the descending order itself. A2 minus A1 or AK plus 1 minus AK. It should go in this order itself. Okay, that is about the arithmetic progression and the general form of arithmetic progression. We are left with one more topic, which is nothing but the parameters of arithmetic progression. The next concept is nothing but the parameters of arithmetic progression. Even before understanding these parameters, we need to understand the definition of two things: finite arithmetic progression and infinite arithmetic progression. Say for suppose I'm considering a series like 3, 5, 7, 9, 11. That's it. This is a series. And I'm going to consider next one as 2, 4, 6, 8, 10, and so on. This particular series, the very first one, you know the last term of this series. But for this particular series, even though you know this as an even number series, you do not know where it is ending. Okay, the series, the arithmetic progression, the AP, arithmetic progression, for which you do not know the last term. You means we. Okay, we do not know the last term. He is known as infinite arithmetic progression, and for which you know the last term. Here the last term is 11. The AP for which we know the last term is known as finite AP. All right. So now that we understand what is a finite AP and what is an infinite AP. Okay, finite and infinite AP we are aware of. So what happens now? Parameters of AP. What are the parameters? Nothing but whatever you got to know. What is the first term? What is the common difference? These are nothing but the parameters of AP. So what is coming to the parameters? The first term is A. Common difference is nothing but D. When what is the need to know the parameters of AP? Because in the coming as we start on the exercise problems in the next videos, the questions comes up like they will give you the list of numbers and ask you whether to identify whether this is an AP or not. For that you need to know the list of parameters of AP. So given a series like this 2, 4, 6, 8, 10 and so on, they will ask you something like this and so on. Figure out whether this is an AP or not. This is an AP or not. How do we identify this? Here the first term is 2. The common difference A2 minus A1 is 4 minus 2 is equal to 2, and A3 minus A2 is 6 minus 4 is equal to 2. A4 minus A3 is equal to 8 minus 6 is equal to 2. As we are getting the same thing for all the numbers that are given in the list, hence we say that the difference is same. Therefore, the common difference is 2. A is 2, common difference is 2. And as we have a common difference in this list of numbers for all the consecutive numbers, this is said to be in AP. That is the reason we need to understand the parameters of AP. Alright. So far what we have discussed, what do we understand from the term progressions? What is the meaning of progression in terms of general scenario, and in terms of mathematics, what is a progression? What are the types of progressions? Within that we have started the arithmetic progression today. What is an arithmetic progression? What is the general form of arithmetic progression, and what are the parameters for arithmetic progression, and how do we identify whether a series is in AP or not? Alright, that is about this video. In the coming video, we will be starting on the exercise problems. Alright, so as usual, as before I close the video and before I start the exercise problems, my suggestion to you people is to go through the examples, because examples are the ones which will make you understand the trick in solving the problems. So please go through the examples before watching the next video on exercise problems. Alright, till then keep watching Anantha Lakshmi Academy. Also please do circulate with these videos with your friends if you find they are worth watching and you are able to understand the content. Thank you.